Okay, so now we're going to finish the notes for section 5.1 trigonometric identities. Today we green penned and turned in homework A, and homework 1B is due on Monday. And homework 1C will be due on Tuesday. I don't have it written on the board yet, but I will hopefully by the end of the hour. So now we're looking at number 5, and we're simplifying the cosine x tangent x minus sine x cosine squared x. So simplify means to, kind of shorten it up, make it into something that is less than this. Sometimes we're uncertain of how to attack that kind of a problem. But one strategy is to turn everything into cosines and sines. And sometimes I'll try to maybe write in yellow and then get rid of the yellow. So when I look at this, there's cosine, sine, and cosine. So this is tangent. Maybe if I turn everything into sines and cosines, it will be, it will give me something that will make that a little bit easier to use. And so my plan is to change tangent theta is equal to sine theta over cosine theta. And just kind of see what happens. So that will give me over here cosine x times, and then when I put that in, sine x over cosine x. I'm kind of writing it so that I can see where the fraction is as I go to kind of help me along, minus sine x cosine squared x. In the back of my mind, I'm also kind of keeping an eye on that cosine squared x. Maybe that'll give me something related to a problem where I get to use a Pythagorean identity. Then here I can cancel the cosines because that was over 1. And then I get sine x minus sine x cosine squared x. Oh, and I misspelled here. Let me fix that. What do you notice then if you're looking at that? Sine is a common factor, and so I'll factor that out, sine x. When I factor out sine x, just remember it's sine x divided by sine x, which is 1, minus, and then when I take this whole thing and divide that by sine x, I get cosine squared x. So this is 1 minus cosine squared x. And when I look at that that's in parentheses there, I'm like, oh, there's a 1 and there's something squared. It reminds me on my note card, which probably should be out in front of you, that I know that the sine squared plus cosine squared theta, sine squared theta plus cosine squared theta is equal to 1. So we've already kind of talked about this yesterday. That means the sine squared theta is equal to 1 minus the cosine squared theta. And I can do a substitution right there. So that should shorten things up for me as I go. So that means the sine of x times the sine squared of x. And then in this case, sine of x times sine squared of x is sine cubed of x. And that would be considered simplified. It's much, condensed and shorter than the original. One thing I'll say is if, and this I might circle in yellow and just kind of leave. If you want to check this, we talked about validating on the calculator. If you put in as y1, the first thing that I circled in yellow, and is y2, the second thing that I circled in yellow, and then you look at a graph, they should match each other. A table of values, they should match each other. That's a way to validate that your answer is equivalent to the other one. It doesn't necessarily guarantee that it's the most simplified form, but it gives you equivalence. And I'm just going to tell you, kind of leading into the next section, or the later in the chapter, when we're proving identities, then sometimes we'd have this one of these two yellow things set equal to each other, and we would work just like we did to get kind of one side of the equation to be the same as the other side of the equation. I don't really remember what's on my slides here, but there we go. Here is this typed in. I think somebody had asked me how to type in cosine squared x. You can't type it like that. You can do cosine x and square it like that, or you could just do cosine of x times cosine of x. That would be another way to square it, but we can't put that square within there like we're used to as we go. And so those are just some things to kind of think about as you go through that. Now, the next one is we're going to simplify this one. So you can kind of write that down. I'll write it, but that'll be what I manipulate. The secant of x over 1 minus the secant of x minus the secant of x over 1 plus the secant of x. When I'm thinking about my plan here, simplify often is going to mean that I want to, take two fractions and make it into one fraction. And so I want to get a common denominator. We talked yesterday about using a conjugate. Do you remember that? And where it's, a plus, we talked about it for complex numbers, a plus bi, a minus bi, and then the i's dropped out, and we got a real answer. Well, here we're multiplying by two things that have just the opposite sign for the second part, and then the middle terms kind of drop out. So my common denominator is just going to be 1 minus secant x times 1 plus secant x. And so that's what I'm going to kind of use as my guide to do this. So I'm going to get a common denominator. If I can write it as one fraction, maybe some good things will happen to me. So this one's 1 minus secant x, so I'm going to multiply times 1 plus secant x. And to not change the value, I have to do that 1 plus secant x over 1 plus secant x. Anything that has two terms, I'm going to put a parentheses in so I remember to distribute or FOIL. Then over here, I have the 1 plus secant x, so I'm going to multiply by 1 minus secant x. 1 minus secant x. Oops. And again, anything with two terms, I want to make sure that I'm careful to put a parentheses. Just a note to self, this is a minus sign, so when I distribute this thing through there, I'm gonna distribute that as a negative secant x, just to kind of think that through as we go. Then I'm just going to distribute and FOIL. I'm going to distribute from the back here, and hopefully you agree that I can write this as one fraction. Actually, I'll do that right away. One fraction with that denominator, 1 plus secant x, 1 times 1 minus secant x, and that's my common denominator now. So it's going to be all one fraction. Secant x times 1 is secant x. Secant x times secant x is plus secant squared x. I'm distributing this as a negative secant x. Negative secant x times 1 is minus secant x. And negative secant x times negative secant x is plus secant squared of x. That's my big, long numerator, or top of my fraction. Then on the bottom, I can FOIL either one of those other two things and get that denominator that I need. And I'll do some of that work in my head. 1 times 1 is 1. Outside terms is minus secant x. Inside is plus secant x. Those cancel out. That's exactly what I wanted to have happen. And then I get minus secant squared x. Hopefully you're noticing lots of good things happening. What's something that happened? Yep, I can cross out the secant x and minus secant x. And then on the top, I get 1 secant squared x plus 1 secant squared x. And I'll just do that right now. That's 2 secant squared x over 1 minus secant squared x. Question, can I cancel the secant squared x's? Give me a head nod for those of you in the room. Can I do that? No, the head nods are no, I cannot do that. And the reason I can't is these are subtracted and so everything isn't a factor. But when I'm looking at, and I'll get rid of that yellow thing, but when I'm looking at that, that should make me think, oh, I wonder if there's a Pythagorean identity that I could apply to this problem and kind of, make that into a single term kind of thing. And yes, I have tangent squared, and so I'll write that. Tangent squared theta is equal to, or excuse me, plus 1 is equal to secant squared theta. So tangent squared theta plus 1 is equal to secant squared theta. And then if I want to, oh, my bad, just a second. I was going to get rid of this yellow thing and then I didn't. So now I have that. I have though on my problem 1 minus secant squared theta. And so I'm going to say, you know what, I'm going to leave that 1 right there. I'm going to subtract secant squared and I'm going to subtract tangent squared from both sides. When I do that, I'm going to get 1 minus secant squared theta equals negative tangent squared theta. Give me a head nod if everybody's with me on that. Because I feel like if you guys are, just kind of generally people will be with me. And so then on this one, and I'm going to kind of go down a little more so I won't be able to see all of that. So then this one is going to be 2 secant squared x over, and then this one is negative tangent squared x. And you might be saying to yourself, well, that is more simple than to begin with. Maybe it's a single fraction, and so that's a little bit better. But, I kind of think in my head, well, secant is 1 over cosine, and tangent is sine over cosine. So I wonder if I could have something happen where something more will cancel out. And so then the next thing I'm going to do, and I'm just going to use, really, I'm just using this quotient idea that secant is 1 over cosine. So, secant squared will be 1 over cosine squared. And tangent is sine over cosine, and same thing. So I'll just write those there. Secant theta is equal to 1 over cosine theta. And then I'll use a different color and say tangent theta is equal to sine theta over cosine theta. So then I'm going to substitute those in. I'm color coding, so I'll have to be a little careful as I do this. But my 2 and my fraction bar stay the same. Secant squared turns into 1 over cosine squared of x. And so that's really like 2 over 1. I should have maybe written it a little higher. And then the tangent squared, negative tangent squared theta, the negative kind of stays there, and that's sine squared x over cosine squared x. And then I am going to start moving this way because I'm going pretty far down here. This top of this fraction is 2 over cosine squared x. So I'll just write that 2 over, oops, in green, I'll write it. 2 over cosine squared x. And then I'm going to take this bottom part and I'm going to invert and multiply. It's negative, so it stays negative. So I'll write that as negative still, but then cosine squared x over sine squared x. And then I should feel super happy. Do you agree? I should feel super happy because my cosine squareds will cancel out. And that's what I'm going to do next. I'll cancel those out to be ones. And then I end up with 2, excuse me, -2. I almost forgot my negative there. -2 over sine squared x. And maybe if it were maybe if it were not a fraction, that would make me happier. So I also know that sine is 1 over cosecant, or cosecant is 1 over sine. So I could think of this as -2 times 1 over sine squared x. And then I'm going to remember that cosecant theta is equal to 1 over sine theta. And so then I can make this -2 times cosecant squared x. And without the dot, because I just don't need the dot, that would be my answer. And so notice this. I went through a lot of steps, and that's kind of why I'm assigning less problems as we go through these, just to kind of be able to make sure that we're seeing all these steps as we work out problems. Our problems are going to have more steps as we go through them. And two people could approach a problem very differently and end up with the same result at the very end. As a matter of fact, like in this problem, I could have started this problem and just changed all. Okay, so now we're moving on to number 7, and those of you who weren't here today, you missed a wonderful little lockdown drill, so too bad for you. And so this is example 7. We want to rewrite this fraction as an expression that does not involve a fraction. So one thing I'm going to comment on this is we don't want to be super in a hurry to get rid of the fraction. We want to just maybe do whatever we can from our note card and then sort of see what happens. So this is 1 plus tangent squared x over cosecant squared x. And in my plan over here, or thoughts, or whatever I want to call it, I'm going to notice that tangent squared theta plus 1 is equal to secant squared theta. So tangent squared theta plus 1 equals secant squared theta. And maybe you're kind of noticing or remembering, that as we're doing these, like secant is 1 over cosine, cosecant is 1 over sine. So I feel like good things will probably happen to me as I go through this one as well. So I'm going to do a substitution, and then I'm probably going to change things into sines and cosines, change things. Oh, this is number 1, and then change things into sine and cosine, and then just kind of see what happens. And if I need more planning after that, I will do more planning after that. So this first one is I'm replacing that 1 plus tangent squared theta, or x, with secant squared x, and that's still over cosecant squared x. So that's the first thing that I did. And now I'm going to just change those into sines and cosines. So I will give myself a little note that secant theta is 1 over cosine theta, and cosecant theta is 1 over sine theta. And so definitely let me know if I make a mistake there. And so then I'm going to change this secant squared into 1 over cosine squared. And so that's going to give me 1 over cosine squared x all over, this is kind of still left from the beginning, then this cosecant squared x is going to be 1 over sine 1 over sine squared x. And then I'm going to do the invert and multiply. So 1 over cosine squared x stays the same. And then I'm going to multiply that times my sine squared x, or 1 over sine squared x, I'm going to invert and multiply. So that'll be sine squared x over 1. And then I just multiply straight across, and I get sine squared x over cosine squared x. And then my job was to write it without a fraction. And so notice up until now, I've had a fraction the whole time. It hasn't worried me. I don't know if it's worried you. But when it says get rid of the fraction, don't be in a super hurry to get rid of the fraction immediately. Otherwise, you can get kind of some wild things. Because now I feel like, oh, wow, it's going to be easy for me to get rid of the fraction because tangent theta is sine theta over cosine theta. So I'll be able to kind of get rid of all that. So I'll just remind myself to use the fact that tangent theta is equal to sine theta over cosine theta. And so, you know, really this piece here, I can think of that as sine x over cosine x, you know, squared, and then make it tangent squared. But I think we're pretty, hopefully, pretty good with kind of thinking that through and just saying, oh, that's going to be tangent squared x. And so that's what I'm going to say it is, tangent squared x. And that is without any fractions, and it actually turned out to be quite a simplified, short little version. Now, don't think everything comes down to a single trig function, because it often doesn't, you know, and as we move into other sections, you know, we're just going to be manipulating things. And that's what you want to be practicing, just manipulating things, using your note card, even if they don't always work out. I would say always give a try at a problem. If it doesn't work out, you know, kind of cleanly after a while, you could try it again, and then if it doesn't work out, just kind of go with it and then ask me about it as we do things. Because for these, I'm usually looking for if you're attempting things. So this is definitely a place where we want to show our work as we go through things. And we'll check our answer in the end. But this is sine squared x, this is, you know, maybe you want to call it 7b or something, I don't know, over 1 plus cosine x. This has some similarities to like number 6, where we had the two fractions, 1 plus secant x and 1 minus secant x, but now it's just a single fraction, and we might think that this first step isn't really going to get us away from a fraction, because it's not, but we have this added thing in the bottom of fraction. And do you agree that having something added or subtracted in the bottom of the fraction is harder than if this fraction were flipped upside down? In my mind, that makes it a little bit harder. So I want to handle this denominator that I don't like that much. And I want to think about the fact that whenever I have, you know, 1 plus some trig thing, that its conjugate is 1 minus that trig thing, because that is going to give me like something that I can apply a Pythagorean identity to. And so that's what I'm usually thinking of. And really, even if it hadn't had the 1, if I had sine plus cosine, or secant minus tangent, I might still use that conjugate idea to kind of get something that's going to be a little more manageable as I go. And I apologize, but I have to get rid of my yellow right now. So those are kind of things I'm thinking about as I go. So my first step is I'm going to multiply by the conjugate. Maybe that's how you spell that. So that's 1 minus cosine x. and 1 minus cosine x. And so again, you might be saying to yourself, well, what is that going to do to get me, rid of my fraction? Nothing immediately, but hopefully down the line it will. And then there's this another thing to contemplate. This bottom, I want to FOIL that out for sure because I know it's going to give me something on my note card. But the top, sometimes I want to multiply it out, but I just keep in mind that sometimes if I multiply it out, I might redistribute it. Distribute is the wrong word. Well, it's using the distributive property, but undistribute it, so I separate it. So having seen this, and not done many of these problems together, I would probably distribute that right away. But later in my mind, I might do this step first and leave that momentarily. But probably when you attack a problem, that's what you're going to do. So I'm going to go sine squared x minus, and then this, however you write it, is either sine squared x, cosine x, or I could have written it cosine x, sine squared x. Whatever happens there is just fine. And so I've got that on the top, or the numerator. Then when I FOIL this, 1 times 1 is 1. Outside terms minus cosine x, inside terms plus cosine x, and that cancels out. And then when I multiply last terms, I get minus cosine squared x. And then I want to notice, okay, that is another, relationship to the Pythagorean identities. And so I know that sine squared theta plus cosine squared theta equals 1. So sine squared theta plus cosine squared theta equals 1. Now, after this week, except we've had a lot of people in and out of the room, I'd like to just be able to look at these and manipulate them over here without having to write them there. Would you be good with that, everybody who's in the room right now, which isn't, of course, our whole class? So, in my mind, I might say, oh, really, just if I was looking at that, if I subtract that, 1 minus cosine squared is sine squared. And so I'm going to put that over there. Sine squared theta is 1 minus cosine squared theta. And so then that's what I'm going to do here. So I'm going to leave the top alone for a minute. Sine squared x minus sine squared x cosine x. And then this 1 minus cosine squared x is going to be equal to sine squared x. So then I'll just write that. So that's sine squared x. Now, let's think back way to the beginning here. And so I'll write in yellow again. We multiplied that because that's probably what you would do, right? Give me a head nod if that's what you would have done. Absolutely. I anticipate that that's what you would have done. But think about what it was way up there, right? And do you notice that way up here, it's sine squared x times 1 minus cosine x. And so this is in factored form, and now I have that sine squared x. Do you see how if I'd have left it like that, those would cancel right away? You with me on that? So, but that's okay because I wouldn't have maybe thought to do that immediately. But now that I'm looking at it, I can say, oh, you know what? Yeah, I can refactor out that sine squared x. So sine squared x times 1 minus cosine x. And that's over sine squared x. And then now, as long as they're factors, everything's multiplied, I can cancel those to be 1s. And my answer is 1 minus cosine x. And so then I'll look at my multiple choices, and I'm like, ooh, I think it's C. And let's check. Yay. So, so that's what I'm doing. And your level of frustration might be high on some of these problems. That's why there's only like 12 in the first assignment. And I didn't still write up that second assignment, but I will right now. And there's 13 in the next one. So when you're doing a problem, if you get into like a big mess, because that's what's going to happen, and that's okay. If you get into a big mess, just kind of hold off, or once it's a real big mess, don't try to go back. Just start over if you want to do it again or whatever and see if it's going to work. Um, and then you can also ask me about it. So that's it for this lesson, and we're now done. Think about your level of understanding. And remember, when you're frustrated, I'm a little happy because you're learning. Have a good day.